My company, Moriseki, is very honored to be here today, so thank you for the invitation. I want to briefly mention that I guess we had three questions. Why is there industry in advanced manufacturing industry? What processes does your organization use, and what are some of the challenges? And 10 minutes is really difficult to go through that. So we're right down the road in Davis. We're building a new manufacturing facility there. And I want to just extend the invitation to anybody here. Come out if you want to see what we're doing and some of the challenges we face and some of the things we're doing on the advanced manufacturing side. And it's a small world, too. I didn't know one of the professors we sponsor as a company happens to be Dr. Cornfeld. So give credit where credit is due. This slide comes directly from his research. I wanted to first mention the advanced manufacturing. We need to be careful with this definition. I would almost say that everybody in manufacturing now has to be advanced if they want to survive. It's driven by the consumer industry or whatever. Nobody can do it like they did 10 years ago and expect to make money. The margins aren't there. And also when we look at manufacturing, I know a lot of it has been made of the clean tech industry and so on, but it's very important that we look at the whole process chain, the whole product life cycle from the resource extraction all the way to the end user. If we focus on just one aspect, we're leaving 5 or 6 pieces out of the puzzle, and that's a huge opportunity wasted for California. Our company, the circle here, is mainly involved in the manufacturing end of it. So we make CNC machine tools. What are CNC machine tools? Well, they're milling machines that make parts by a subtractive process, and they're controlled by some relatively complex mathematics. And they're one of the fundamental building blocks of manufacturing. In fact, some of the companies here that are presenting, pharmaceuticals, medical, aerospace, our product will be sold to these companies to help make their parts. Briefly, to have good manufacturing, you have to have good design. So we do a lot on the development activity side. We develop the machine tool, of course, but advanced manufacturing is also how quickly and how you can make something and how productive you are making it. So we focus on a lot of automation in our machine tools, and also a lot of the productivity to use the machine tool. What's the use of making something great if the user can't use it very easily? I think maybe that's one of the strengths of the iPhone and why everybody likes it, because it's so easy to use. So we focus on that a lot. Advanced manufacturing for us I could go on for hours here about different examples, but I'm going to just show you a couple real quickly. This is something that everybody can easily recognize, a jet turbine. New materials are needed to make this. Boeing, I think, using a lot of composites on the 787 and so on. So we're making machines and processes that can facilitate those new materials. This is one of our technologies. We call it zero chip. Basically, we have a very powerful vacuum that sucks the waste of the cutting directly through the spindle and into a closed container. And very powerful technology for composites, because you don't want all that dust floating around and people breathing it and so on. So it helps that process to be a lot more effective. I mentioned automation. Here's one example of an automated cell. So people used to think of a machine tool, one person standing in front of it, operating it, and that's the skilled labor that's running that machine tool. That's not the case anymore. Cells are becoming highly automated, so you have to think about a robot loading it. You have to think about automation that hooks into your ERP system, like with your barcoder, and then scanning the part, measuring it once it comes off the machine, all in an automated process. So that's the other thing we do. We try to give our customers a full solution together, rather than just the machine tool. So the idea of skilled workers, I'll maybe address that as one of our challenges later, but the idea is that there are a lot less so-called button pushers. To run the more sophisticated equipment that's being produced does require higher education. There's a gap there, and we need to address it. I don't think you can have a discussion on advanced manufacturing without talking about what's going on to reduce the energy consumption. Nowadays it's becoming more mainstream. Obviously, using less energy means people spend less money, so it's good for business and good for the environment as well. This is the machine that we're going to be making in Davis. Over previous models, this particular machine, through energy saving techniques, we've been able to reduce the power consumption for a single part by approximately 40%. These next several slides are also from the result of Dr. Dornfeld's research. So I'm going to ask him to correct me if I don't give it due justice. Past processes have had a tremendous amount of embedded energy or tear energy, and that means embedded energy such as the HVAC in your facility. The lights are on. When your machine is idle, you're not making something, it's still consuming energy just because it exists. So the other thing that, along with that is when we have past processes would be made on one type of machine, then to get the next process, you'd put it on a drilling machine and then a turning machine, and so on. So you have all these processes. While you're transporting the part between machines, it consumes a lot of energy. And that embedded energy we were talking about with lights on and HVAC and so on, that keeps running. Pumps on the machine keep running. The electronics are turned on and so on. So what you want to do is maximize your spindle time. So even if you design a machine that consumes a lot more energy for the amount of time that it's running, if you can consolidate processes, what happens is you reduce all that tear time between processes, and you dramatically reduce the amount of energy consumed per part. This is very important, staying competitive in the manufacturing environment. And I think in California, especially where people are putting an emphasis on the green technology side. Okay? Good. So we're on Google now in Davis, so that officially means we exist, I suppose. We've had an R&D facility there for some time, and now we're building a manufacturing facility. The manufacturing facility is going to make the machine tool I just mentioned, and it's about 200,000 square foot facility. And for a machine tool manufacturing plant, it's going to be state-of-the-art and use a lot of the latest technologies. And I really don't have time to talk about them in detail today. But one of them is a big automation system. It's called a linear pallet pool system, where we have machines that are fed by more or less a robot. And so the operators are able to load these up, all the parts, and put them in the queue. And as one machine finishes, another part goes in. So we can run these machines 24/7 without people standing next to them. And this is something that we want to use as a showcase for potential customers to see how to improve their processes as well. Real quick on that factory, we're expecting to hire around 150. Our payroll target, we want to be sustainable, so we want to be above the average, but not in the top tier. We'll be able to produce about 80 machines a month at maximum capacity, and our local procurement ratio is about 45%. I have a slide on that later. Gross sales could be up to 160 million. And the investment we put in to do this, not including the land, but the construction of the facility itself is about 27 million, and the capital equipment we're putting in there is another 25 million. So here's the last part, challenges. The California tax and business environment is maybe pointed out by some to be a little bit difficult, but maybe more importantly is the supply chain. I don't think you can manufacture something effectively without a very strong supply chain. And this is not the best place for a supply chain for manufactured parts.